One of the most important things in understanding the behavior of bonds is assessing the sensitivity of the bond price to a change in the interest rate. We've already established that as interest rates go up, bond prices fall, and as interest rates go down, bond prices rise. But bonds are varied in terms of the coupon rate, in terms of the maturity of the bond, and the bond's characteristics determine the extent of the sensitivity of the bond price to a change in the interest rate. So what I want to explore are three concepts of the sensitivity of the bond price to a change in the interest rate. I encourage you to look at the lecture note on bond valuation, class note 1, and also explore the Java-based learning experiences on bond valuation. In these experiences, you can actually input the coupon rate and the maturity of the bond and see visually the sensitivity of the bond price to a change in the interest rate. Well, first let's explore what these sensitivities actually are. What we'd really like to do is to develop a measure of how much the bond price is going to move with respect to a change in the interest rate. And usually what we say for a change in the interest rate, let's say the rate goes from 7% to 8%. What does that mean in terms of the bond price? And usually we pitch this in terms of a percentage change in the bond price. Well, this need for establishing a benchmark or a sensitivity to the change in the interest rate goes far back to some work by Macaulay in 1938. And he's actually the guy that invented the concept of duration. And let me explain to you his concept of duration. Macaulay was dissatisfied with the usual characteristics of bonds that were used to differentiate between different bonds. I'll give you an example. He thought that the term to maturity, or the life of the bond, was a problematic measure of the bond's characteristics. A 30-year bond that has no coupons, or a zero coupon bond, is going to behave much differently than a 30-year bond that's got, let's say, an 8% coupon. So Macaulay tried to establish a way to differentiate these two bonds. Both of them have a life of 30 years. But Macaulay had this idea that the 30-year bond with no coupon, you have to wait 30 years to receive any cash. Whereas the 30-year bond that's got an 8% coupon, it means that you're getting money every 6 months from this bond. So you don't have to wait as long to get some cash. So he said that the effective duration of the 30-year bond with an 8% coupon is less than the 30-year bond with a zero coupon. So this is the genesis of the idea of duration. Now it turns out in my simple example, with a zero coupon bond, the duration is exactly the maturity, 30. So Macaulay would say that the duration is 30 years for the zero coupon, 30-year to maturity bond. And Macaulay provided a formula to actually weight all of the cash flows of the coupon bond. And this formula would suggest that the effective duration of, let's say, an 8% coupon bond with 30 years to maturity is about 12. Now the formula, you can go to the lecture note and see how to work the formula out. But basically what you do is you take the present value of each cash flow divided by the bond price today and multiply that ratio by the actual period that you're in. So if the bond was trading at, let's say, $90, and the first cash flow is, let's say, $5, we take the ratio of 5 divided by 90 and multiply that by 1 for the first period. And the second period, we would take the present value of the cash flow, and let's say the present value of the cash flow is also 5. Divide that by the price of the bond today, which is 90, and multiply by the period 2. And you continue to do this throughout the cash flows of the bond until you get to the final cash flow. And you follow the same procedure, except now instead of doing the bond coupon, you also look at the bond principal value, which is usually 100. So you follow this procedure that's detailed in the lecture notes, and you get a number, which Macaulay called duration. This number roughly tells us the sensitivity of the bond price to a change in the interest rate. So for the zero coupon bond, it tells us that if interest rates increase 1%, and I mean, let's say, from 7 to 8%, it means that the price of the bond will decrease by approximately 30%. Now, I say approximately 30% because Macaulay's measure of duration actually overstates the actual sensitivity of the bond price to a change in the interest rate. So what we usually do is to modify Macaulay's measure of duration to get a more exact formula. So what we do is we take the Macaulay measure of duration and divide by 1 plus the effective interest rate. So in the case of the zero coupon 30 year to maturity bond, the modified duration is given an interest rate of, let's say, 10%. The effective duration, or the modified duration, is about 27. So this implies if interest rates go up by 1%, the bond price approximately drops by 27%. And this is more exact, and usually when people talk about duration, they're really talking about modified duration. Now, there's a lot of mathematical intuition about the duration measure. And really, what the modified duration measure is the slope of the bond price function with respect to the interest rate. So if you look at the Java learning experience on bonds, you can visually put a slope to any point on the graph. And the slope measures the modified duration. And the slope is negative. And that simply means as interest rates go up, the bond price goes down. Now, in terms of this simple example that we've been working with in the zero coupon bond, you can see almost immediately that the sensitivity of these bonds to changes in the interest rate can be dramatically different depending upon the maturity. So the 1-year bond has a modified duration of approximately 0.9. So that means that if interest rates increase by 1%, this bond price will drop by approximately 0.9%. But for the 30-year bond, if interest rates increase by 1%, the bond price is going to plummet by 27%. So you can see that there's a big difference between the sensitivity of a bond with the same coupon, in our example 0, and the maturity. So the longer the maturity, the more sensitive a bond is to a change in the interest rate. Now, it's also true if you fix the maturity. So let's say we fix it at 30 years and consider two bonds. One is a 0 coupon bond, and the other is a bond with an 8% coupon. The 0 coupon bond has a modified duration of approximately 27. The 8% coupon bond has got a modified duration of approximately 12. So if interest rates increase by 1%, the 30-year bond is going to drop by 27% with the 0 coupon, and the 30-year bond with an 8% coupon is only going to drop by 12%. So it's also true that as the coupon increases, the sensitivity of the bond price to a change in interest rate decreases. The maximum sensitivity that you can have is with a 0 coupon bond. Now, the mathematical intuition of this is quite simple. With a 0 coupon bond, all of your cash occurs in the final period. And that final period is discounted back to the present value by dividing by 1 plus the interest rate raised to the power of the number of periods you're bringing it back. For the 30-year bond, that is quite a large exponent hitting the interest rate. So any small change in the interest rate is going to be magnified by the power of the exponent. So as coupons increase, the sensitivity of the bond price decreases. Okay, and this has to do with the geometric compounding. It has to do with cash coming later rather than sooner. Now, there's a third measure of sensitivity, and it's very much related to the modified duration. Often what we do is we take a particular bond, and let's say it's an 8% coupon bond with 20 years to maturity, and consider what happens if the interest rate increases 1% and decreases by 1%. So suppose the situation is that we've got an 8% coupon bond, and it's got 20 years to maturity, and the current interest rate in the market is also 8%. This bond would be priced at exactly 100. When the interest rate in the economy matches the interest rate on the coupon, then the bond is always priced at 100. Now what we can do is to calculate the price of the bond if interest rates go up by, say, 1%. So rates go from 8% to 9%. Now we know that as rates go up, the bond price should go down. So we can calculate the drop in the bond price. And roughly speaking, the bond price would probably go from 100 to about 92. Then what we can do is calculate the percentage change in the bond price. And obviously, in this example, the prices drop from 100 to 92, which is 8%. Next, what we can do is to calculate what happens if interest rates decrease by 1%. So they go from, say, 8% to 7%. We know as rates decrease, the bond price should increase. So we can go do that calculation and figure out what the percentage change in the bond price would be. And we know the bond price will increase. Next, we take the percentage change in the bond price when interest rates go up and the percentage change in the bond price when interest rates go down by 1% and average the two. This is called the bond price elasticity. And it gives us a measure of the sensitivity of the bond price to a change in the interest rate. It turns out that this measure is very similar to the modified duration measure. It's an approximation to the modified duration measure. And mathematically speaking, as we look at smaller and smaller changes in the interest rate, so instead of going 1% up and 1% down, we go 0.5 up and 0.5 down, or 0.1 up and 0.1 down. As those rate changes get smaller and smaller, we're going to get closer and closer to the modified duration measure. So often we calculate price elasticity and modified duration and use the two terms interchangeably. So these measures, the modified duration and the price elasticity, are useful measures for assessing the sensitivity of the bond price to a change in the interest rate. It gives the bond an extra characteristic that is quite useful for an investor. It's one thing to know the maturity, one thing to know the coupon, another thing to know the price. But the question is, what happens to the price of this bond if interest rates increase by, say, 1%? Having the modified duration and having the price elasticity give us the information that we need to assess the sensitivity.